Welcome, everyone. Okay, let's dive straight into this incredibly important explainer today. We are unlocking the high-stakes world of Cambridge AS and A-level physics. Now, while our main focus is on the notorious subject code 9702, specifically the variation of binding energy per nucleon with nucleon number, the strategies we're unpacking today apply across the board, whether you're sitting 0625, 0651, 0652, or 5054. We're going to look at this complex physics topic through a very, very specific lens. We're giving you an exclusive, behind-the-scenes look straight into the examiner's playbook. Think of this explainer as your ultimate strategy guide. I want you to adopt the mindset of a master tailor or high-end fashion designer. Seriously. Why a fashion designer? Because to get top marks, you absolutely cannot just throw a random bunch of physics facts at the page and hope they somehow stick. You have to tailor your answer to fit the exact contours of the question perfectly. No loose threads, no wasted words, just precise, beautifully structured responses. We are going to transform the way you approach these exams entirely, taking those heartbreaking red pen marks and turning them into incredibly satisfying green check marks. So, right off the bat, we have to ask, why do genuinely brilliant physics students constantly lose marks on binding energy questions? I mean, it happens in literally every single examination series. You see, mastering the raw facts of nuclear physics simply isn't enough anymore. I want you to imagine two different students in the exam hall right now. Let's call them Alex and Sam. Now, Alex is a walking, talking physics encyclopedia. Alex overloads absolutely every single answer with raw physics facts, writing massive paragraphs of data, but provides absolutely zero structured analysis. It's just a data dump. Then we have Sam. Now, Sam knows the material just as well, but Sam rushes through the exam in a panic, constantly missing the specific requirements of the command words. Sam drops so many easy marks purely because the answer isn't formatted properly. Both Alex and Sam are brilliant, hard-working students, but neither is capturing maximum marks. Why? Because they lack a structured, analytical reasoning framework. Examiners aren't just looking for what you memorized. They are rigorously, ruthlessly testing how you think, how you structure your logic, and how you present your evidence. If your answer isn't perfectly tailored to the precise assessment objectives, your raw knowledge is just going to go unrewarded. So here is the exact masterclass structure we're going to follow today to build your exam strategy from the ground up. First, core physics principles. Second, the standardized sequence. Third, the method mark strategy. Fourth, top 3 examiner warnings. And finally, mastering comparative analysis. Let's get right into it. Section 1, the core physics principles beyond superficial breadth. When you're dealing with syllabus 9702, you really have to understand that examiners aggressively prioritize analytical depth over just knowing a little bit about a lot of things. They absolutely do not want a brain dump. They want a laser-focused, deeply analytical response. And this brings us to the very first hurdle, terminology. Look closely at the exact phrasing required by Cambridge. It's not just binding energy. You can't just write that and move on. It is the complete, precise concept, the variation of binding energy per nucleon with nucleon number. Examiners have noted time and time again in their reports that students struggle with the distinction between basic terminology and these complete, rigorous definitions. Why does this matter so much? Because using the precise terminology is your gateway to demonstrating what the examiners specifically call connected conceptual understanding. They demand analytical depth. More importantly, they want to see your ability to transfer this deep understanding to entirely unfamiliar contexts. If you only have superficial breadth, kind of like our hypothetical student Alex, you will completely falter when the examiner asks you to apply the concept of binding energy variation to a novel isotope or a theoretical nuclear reaction. Your terminology must be razor sharp. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, so understanding exactly which cognitive domains the assessment objectives are targeting is absolutely crucial here. These are the 3 pillars you must master. First, knowledge and understanding. This is your baseline, right? Just knowing the definitions and the core phenomena, but honestly, that is just the starting line. Second is application. Can you take that foundational knowledge of binding energy and actually apply it to an unfamiliar graph or a complex mass defect calculation? And third, the big one, analysis. This is where you deconstruct the data, evaluate the relationships, and draw completely justified conclusions about whether a nucleus is likely to undergo fission or fusion. When you are writing out your analysis, you should be using structural frameworks like the Peel framework, point, evidence, explanation, link. Make your point, back it up with data from the graph, explain the physics principle, and link it back to the specific question asked. Top-performing students don't just memorize, they adapt. They smoothly transition between knowing the facts, applying them to the specific question asked, and analyzing the underlying physics using solid frameworks. If you want to stop bleeding marks, you need to consciously ask yourself during the exam, am I just showing knowledge here, or am I actually applying and analyzing as the question requires? Moving on to Section 2, the standardized sequence, the procedural framework. If you want to avoid being like Sam, the student who rushes, misses command words, and just leaves points on the table, you need a systematic, repeatable way to process complex binding energy problems. You literally need a method that guarantees logical reasoning every single time you put your pen to the paper. The principal examiner reports reveal that systematic processing always follows this exact 5-step standardized sequence. We call this the physics success blueprint. Step 1, identify key elements. Deconstruct the question. What exactly are they asking? Decode the command words. Are they asking you to state, describe, or explain? Extract the relevant data. Step 2, apply relevant principles. Select your analytical framework. Are we talking about fusion, fission, or maybe the stability peak near iron 56? Step 3, execute analysis with clear working. This is where you lay out your mathematical or logical steps visibly. Absolutely no skipping steps in your head. Step 4, verify results. Take a moment to evaluate your own performance. Ask yourself, does this numerical answer actually make physical sense within the context of nuclear physics? Step 5, present an appropriate format. Use proper headings, the correct precise terminology we just discussed, and clear annotation. By following this exact framework, you guarantee that your reasoning is structured and your presentation is highly professional. This is exactly how you tailor your answer perfectly. Section 3, the method marks strategy, process over perfection. Now, we've derived a massive tactical insight directly from the Cambridge Principal Examiner reports, and I'm telling you, it is a complete game changer for your exam performance. We have a direct, glaring examiner alert here. Listen to this. Students lose marks by not showing working. Even if your final answer is wrong, method marks can save you. I literally cannot emphasize this enough. So many brilliant students calculate a complex binding energy variation in their head, write down the final numerical answer, make a tiny, silly arithmetic error, and score 0. 0 marks for a question they actually fully understood. It's heartbreaking. The ultimate safety net in the Cambridge 9702 exam is showing your clear notation and your step-by-step execution. When you write down the formula, when you explicitly show the substitution of the nucleon numbers and the energy values, you are banking method marks. You are proving to the examiner that your process is completely sound, even if your calculator finger slipped at the last second. Remember step 3 from our framework? Execute analysis with clear working. It is non-negotiable. Now, stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Let's dive into Section 4, Top 3 Examiner Warnings, Avoiding Common Pitfalls. Think of this next part as a bit of an interactive workshop. Let's look at the 3 deadliest traps where students needlessly bleed easy marks during these specific nuclear physics questions, straight from the people who actually grade your papers. Let's find the flaws. Warning number 1. Students completely forget to include proper format in their answers, losing easy marks. The solution? Always use strict conventions and appropriate terminology. If the question asks for unit, give the unit. Warning number 2. Students forget to check format and presentation. They write these messy, unannotated derivations that are impossible to follow. The solution here? Use clear annotation and structure your working logically. Make it easy for the examiner to give you points. Warning number 3, and honestly, this is a huge one. Answers are not specific to the context given. Like our student Alex from earlier, they just write everything they know about binding energy rather than tailoring it to the specific nuclear reaction or isotope the question actually asked about. The solution? Deconstruct the question and extract only the relevant data. Don't write a novel, write a targeted answer. If you can actively scan your own answers for these 3 specific flaws before you turn your paper in, you will instantly protect your grade. And finally, Section 5, Mastering Comparative Analysis, Higher Order Assessment. We are now dealing with the heavy hitters, the higher order assessment objectives. This isn't just about describing a graph anymore. This is about critical analysis, evaluating alternative approaches, and making completely justified recommendations based on the quality of evidence. This right here is what separates the A grades from the A-star grades. There is a massive difference between an average answer and a top-tier answer. On one side, we have superficial analysis. This is just listing facts, saying things like iron has a high binding energy or uranium has a lower binding energy. That is merely descriptive, and it absolutely won't get you maximum marks on a higher order question. On the other side, we have evaluative analysis. This is where you evaluate evidence quality by identifying limitations and assumptions. Crucially, comparative analysis requires identifying similarities and differences. And the absolute secret weapon here, comparative connectives. Words like whereas, conversely, in contrast. A top-tier answer sounds like this. While isotope X exhibits a rapid increase in binding energy per nucleon, indicating high probability of fusion, isotope Y, conversely, sits past the stability peak, meaning. Do you hear the difference in that phrasing? You must support each comparison with concrete evidence and draw justified conclusions about their relative importance. You must be evaluative, not just descriptive.
So how on earth do you remember all of this under the immense pressure of the exam room? Well, here is your final, highly practical memory hack to bring this entire system together. It's a simple acronym based on the first letters of our procedural framework, IAEVP. Identify the key elements, apply the relevant principles, execute analysis with clear working, verify your results, present in appropriate format. IAEVP. I want you to memorize this. Literally write it at the very top of your scratch paper as soon as the exam begins. Whenever you feel stuck or panicked on a complex binding energy question, fall back on this sequence. It will force you out of a panic state and right back into a structured, logical, and examiner-approved methodology.
So the crucial point we end on today is a choice. Will you let your hard-earned physics knowledge go completely unrewarded because of poor structure, rushed reading, and superficial answers? Or will you execute exactly like an examiner, using precise terminology, showing your step-by-step working to secure those method marks, and delivering highly evaluative comparative analysis? Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here. Keep practicing those past papers. Tailor your answers perfectly like a master designer. Always fall back on the IAEVP framework and execute like an examiner. You've got this.